Hi, everyone. A very good morning, good afternoon, good evening to all of you. I hope you all are sound and safe. And I hope you all are very excited for this particular webinar on how to build a competitive robot. I will soon be introducing the master trainer of this session. But just before that, I would like you to make this session as engaging as possible. So make sure to drop in your name and the country name from where you are tuning in from, just like I'm dropping mine. Good evening, Rajvi. Good evening, Luck. Good evening, everybody. So we are very excited for this webinar since we will be covering a lot on how exactly you have to make your own competitive robot that you will be using for track 2 specifically, but of course you can learn from this particular webinar and we make a robot configuration for track 1 as well. We have people joining us from India, and what other countries? Comment down. We will be starting up the session in another 2 minutes. Then we will take it forward. But till the time, I request all of you to be as interactive and as engaging in the live chat box. Drop in your name, your country name, and we will be more than happy to interact throughout the session. So we have Aman joining us from Canada, Geet from India, Jyoti from India. So nice to have you all. So I think without further ado, it's the right time to start up the session. So once again, a very good evening, good afternoon, or good morning to everybody who is joining us live for this webinar. So I'm really happy to have you all here to understand how exactly you can start building a competitive robot that you can use for Codeavour 6.0 International. So without further ado, let's start up with the itinerary of this session. Let's understand what exactly you will be learning and what we will be covering in this session. So we will be giving you an introduction about robot, what exactly a robot is, then introduction to robot building as well. So what are the aspects one needs to understand while they are creating their own robot configurations? That will be covered up by our master trainer who has joined us. Soon I will be introducing her to you all. Then we are going to talk about the key consideration that one needs to take in while building a competitive robot. So what are the notes or what are the points that one needs to remember and take a note onto while building such a robot? Then you're going to also understand what are the steps or what are the step-by-step progression one needs to take up for this competitive robots that they will be building, and of course, what are the materials and tools that you will be required. So basically, in this particular webinar, you will be able to understand and grasp the knowledge of how exactly robotics work and how exactly you can create your own competitive robot that you will be using. So just to give you a gist and just to revamp our knowledge, this particular Codeavour 6.0 International has a theme of sustainability and climate change, in which we have two tracks. First is track 1, which is of entrepreneurship, innovation and entrepreneurship, in which students will be showcasing their unique and innovative ideas, and they will be pitching those ideas to the judges in regionals, nationals, or internationals, depending on the country. Then we have track 2, which is climate action challenge. In this particular track, you will be required to have that competitive robot that you will be learning how to create, and you will be completing several challenges. So there are 8 challenges that one needs to take up within a time frame of 3 to 4 minutes. You have to complete as many challenges, and then from there on, you will be evaluated. So this is about track one and track two. You can know more about track one and track two through the Codeavour website. So kindly visit codeavour.org. Just type it in the web browser and know more about the same. Just a quick highlight on the guidelines as well. The Codeavour competition, the Codeavour Innovation Fest, is divided into 3 age groups. First is elementary, which is 7 to 10 years old. Then we have junior, 11 to 14 years old, senior, 15 to 18 years old. So these are the age groups in which you can participate in both of the tracks. Then we have a team size, which one needs to take a note on to. So there is a team size, minimum team size can be 1 and maximum can be 3. So there is a team limit of 3. So you can join in with your partner. That means one of your partner, or you can join in with 2 of your partners. So that means you can either have 3 participants in the team or 2, or you can of course participate alone as well as a one man or one woman. Having a mentor is mandatory. So mentor is mandatory if you are participating individually, not with your school. Then you can have your guardian, you can have your parents as your mentor as well. But having a mentor is mandatory. So I think you already got a gist of the theme and both the tracks of Codeavour 6.0 International. You have understood what exactly we will be covering in this session. It's the right time for me to introduce you all to the master trainer, Miss Samriddhi Kori, who is the Codeavour champion. So she has won Codeavour 2020, 21, 22, 23. Yes, she has done it all. She is the champ of Codeavour. She is the alumni and the ambassador. She has been working so hard to innovate and motivate others also. And she has inspired so many creators, and personally, she has inspired me as well through her creations. I have learned a lot from her too. So give a huge round of applause in the live chat box and welcome Miss Samriddhi. Over to you, Miss Samriddhi. Thank you so much for joining in.
Thank you, Vivek sir. Hello everyone, I'm Samriddhi. Hope you all had a nice day. And as Vivek sir mentioned, I'm the 4-time Codeavour champion. And this year I'll be joining you all as a Codeavour alumni. Today I'll be guiding you all on how to build a competitive robot. And also guys, stay tuned till the end of the session because I'll also be sharing my experience during the journey and we'll give you some tips and tricks to win. Okay, so moving on, let's start the session. So guys, what exactly do you think is a robot? Come on, give me the definition of what is a robot in the chat box. What do you think is a robot? What can it do? Probably a few features that you can list out. Let's see. Let's see the chat box getting flooded with the definitions of what's a robot. Come on. Hurry up. Okay, so maybe to give you a hint, robot is a machine. So it helps you do your daily tasks, right? So what are the innovations that you guys want to build? Maybe what are the things that you want to showcase in Codeavour this year? Okay. Okay, come on. Put it in the chat box. Okay, nice. I got a message from Nikita, a machine that takes instructions, which can mimic human behavior. Machine that can perform tasks. Good. Are there more definitions? Okay, a machine. Okay, let me define you what exactly is a robot. Okay. It's a commandable machine, helping machines. Okay. So let me just define what exactly is a robot. Okay, let me give you an example. Imagine you had a toaster. It had legs, it had hands, it could dance, and it also knew when your bread was burning hot, right? So a robot is basically a machine with a bit of brain power, and it can do stuff for us so that we can spend our time doing more important things. Like, maybe go play out a few games, eat a few snacks, watch a movie, something like that, right? So robots are something that help us in our day-to-day tasks. So today we'll be learning on how to build a robot. Okay, so the robot can be a simple dancing toaster, which probably still doesn't exist. You guys can build one of them. Or maybe, a day-to-day object. Have you ever seen how a scissor cuts your paper? Or maybe how does your watch work? It's a smartwatch, right? So basically, all of the objects around you have some mechanical or electronic principles that revolve around it. They usually have pulleys, gears, shafts, or any mechanical systems. Okay. So today you're just not going to learn about the components or mechanisms. You're going to learn about their functions. How are you going to build a robot, the steps involved, the considerations, etc. And if in case you would have participated in Codeavour last year, you might have an idea about how to innovate or how to, compete in track two. So let's move on and help you understand everything about the mechanism and the step-by-step instructions. Okay. So here are a few examples of a competitive robot. Let's start off with the climate bot. So a climate bot is a robot which is built to combat climate changes. Next to that, we have the digital spirometer. It's basically an innovation which has been to combat a respiratory disease, and it interacts with the user in a fun and gamified way. Then we, of course, have our pick and place robot, which just picks one item from one place and drops it off to the other place. And then we also have the smart first aid robot. It's a robot built to provide first aid and treatment to the injured people. Moving on. So we have the steps to build a competitive robot. So guys, I want you to put it in the chat box. What do you think are the main important things that you need to keep in mind before starting to build the robot? Let's say from ideation till the final product, what are the steps that you're going to follow? What are the things that you're going to keep it in your mind? And what are the important things that you need to take care of before starting to build a robot or even during your journey? Anything. Okay, let's see. Let's see what are the chat that you guys have. Uh, yeah. Come on, put it in the chat. What are the steps to build a competitive robot? You can list out one by one. It's okay. You don't have to have everything in one single message. Okay. Coding. Okay. That's a good point. Coding is one of the most important aspects. Then, how do you ideate? How do you move on? What are the things that you need? Yes. Define the problem statement. Good, Srijan. That's an amazing answer. Then, okay. Work carefully. Okay. Research on it, ethics and rules for building a robot. This is very important for track two. Keep an eye on it. The rules are very important, okay? Yeah. Move fast, should not be built in a way to destroy humans. Okay, good answer. Planning, robots in factories. Okay. Connectivity, construct a prototype, assembly line, algorithm. Nice. Hardware, design. Okay. Now let's move on to the few steps. So the first step that you have in building a robot, as someone mentioned, is defining the problem statement. So when you define a problem statement of a robot, you always need to know what is the clear objective that you're trying to solve. What is the problem that you're trying to solve? So you can see the three different videos that are being played, right? So look at the first video. The first video is basically showing a robot harvesting apples. That's its problem statement, is to harvest apples, right? Then look at your second robot. It's performing a surgery. Have you ever seen surgery robots? You realize how much precision they involve? So that's another example. And your third robot is a simple robot, it's just making a girl dance. All three of them have a purpose, right? So whenever you're building a robot, identify the purpose, especially in your track two as well. Look at what is the problem statement given according to the rules and set of instructions given, and accordingly build a robot which can tackle the tasks. And in your track one, of course, a social innovation. Moving on, we have our problem statement definition. So guys, I would like to give you one very, very important tip. So as you can see, these pictures are taken from a notebook and they might look like a scribble pad, right? So when you're ideating, innovating, always maintain a notebook. So once you have a notebook, just start scribbling your thoughts into that notebook. Put your thoughts, the list of features. As you can see, these are from my own projects, Sakhi and Dronacharya. So I've listed out all the features that I want to include in my project. And then what I did is one by one, I looked at how I can solve that particular issue. Then, I have screens and pictoblocks, right? I've just put them into boxes. And, you can make a list of points that you want, add, subtract, always maintain a scribble pad, write down your thoughts, and then you're good to go. Now let's move on to the next important thing, component selection for building a robot. How do you do it? So you can look at the screen. It's a fire extinguisher robot, right? So come on, list out the things that you need in a fire extinguisher robot. What can you see in the picture? So we see a fire sensor, we see microcontrollers, maybe you see motors, pumps. You can see so many of the things, right? So what are these? I've selected components based on a purpose. So first, to detect a fire, what do you need? You need a sensor. Once the sensor detects something, it moves on to a microcontroller to process the information. And once the information is processed, the information goes on to the actuator, and the actuator sends you a command saying spray water. Move the robot forward and spray water. This is the flow of your control. And now for this flow, I've selected particular components, correct? And this is how you're going to do. Let me give you another example. Maybe let's say a robot which measures the moisture level in soil and sends you an alert with a buzzer. Okay. And maybe sprays water as well using a water pump. What are you going to do? You need a soil moisture sensor for it, right? You're going to read the values from the soil moisture sensor, compare it. And once the moisture level goes low, you send it to your actuator, which is not exactly an actuator. It's an output thing, which is called a buzzer. Send it to a buzzer and the buzzer is going to beep. So then the person can come and water his plants. Or you send it to your actuator, which is a water pump in this case, and the water pump releases water and moisturizes the soil. This is a few examples that I can give you. And depending on what you wanted to do, if you wanted to move, you're going to use motors. If you wanted to stay still, you just put it in one particular place. So depending on the problem that you have, how you want to solve it, you can choose various sensors, actuators, microcontrollers accordingly. Moving on, we can move on to the assembly and wiring of the robot. So as you can see in the picture on your right, do you see how the wires are assembled? This is a picture from Saki. So if someone just comes and looks at the robot, will they be able to find out which wire goes where? Do you know what is going on in my mind? No, right? So wiring is one of the most important aspects that you guys can work on. Okay, let me tell you. One wire just gets connected in the wrong place. Do you really think Saki would have worked the way she works? No, right? So I will just give you a few tips that you can use to build a robot, or I would say to wire your robot. First, every robot has multiple features. So separate out the features, keep the separate features separately, and build each feature separately. Once you build everything separately, everything is working independently, then you can combine together and make it into a final project. So looking at Saki, let me tell you an example. It has a safety lock, a fire extinguisher, and maybe let's say a DJ. So I have three different parts to it, right? So first, I'll build the fire extinguisher. It works. Done. Leave it aside. Take another microcontroller. Then on top of that, you can build your safety lock. That works. Then take another microcontroller. Build your this thing, DJ. And once after everything, combine it into a single microcontroller, combine your code, execute it. And that's when you can get an error-free, easier way to, build your project without, many messy wires when you're trying to debug stuff. Then another very important tip that I would like to give you guys is every sensor, let's say a fire sensor, has three pins, right? Positive, negative, analog, or digital pins. Some have four, but you usually use three of the pins. So what you're going to do is combine all three of the wires together, tape it together, and label it, saying fire sensor. Once you do that, whenever you want to connect, imagine you're traveling, you travel for Codeavour from one, for your regionals might be in the place you live, and for your nationals, you might have to travel to Delhi. Then for your internationals, this year is in Qatar, right? So when you're traveling, obviously wires get loose. I mean, unless you solder it, which is advice that I would give you all. But if your wires get loose, what are you going to do? You'll have to find out which wire goes where, right? So label all of them together, and immediately when you go, just connect them together. And another very, very important tip is color code your wires. Okay. Color coding is one of the very important things that I learned as a beginner in robotics. So we all know positive is red and negative is black. Always use the convention. Follow the code, because when Codeavour goes on for about 3 months, right? So when you go from your first month to the third month, you might have not been working on the same project. And when you come back and look at that project, you wouldn't know which wire where you've connected. So that time when it's all color coded, sensors a different colored wire and these two positive, negative, so that you don't interchange them, short circuit them, or it's just easier to wire and it's a convention which you can follow. And if you have a mentor and you send a picture to your mentor and he'll be able to assist you based on the color code. Okay. So these are a few tips I can give you. And if you can, of course, solder the wires. That's one of the best tip I can give you. And yeah, this is about assembly and wiring of the robot. Let's move on to programming the robot. So yeah, programming the robot, a tedious task, right? So programming is a step-by-step instruction that you're giving to a computer. So when you're determining the flow of control, you're going to get confused. When you're building huge robots, you're going to have multiple lines of code. You might have 100, 200 lines of code. You may never know how many lines of code you have, right? So look at the picture on your right. Do you see a flowchart? I'm sure you all know what's a flowchart. It's a diagrammatical representation of the step-by-step instructions you're giving to a computer. Okay? So a flowchart is something for you to look at. So look at my flowchart. This is for Saki, and every orange thing covered there is a different, different feature of Saki. So every feature has its own flowchart. So what I did is each flowchart has been converted into a method in a program. You might have learned about methods, right? You can call them wherever you want. It's like a set of, a separate box of code that you have for a particular action. So make a flowchart into different features, write down the steps that you need to do in that particular project. And once you do that, start coding. And yeah, as I advised you, use methods and ensure that you have separate codes for different features. Same applies for electronic components as well. And always one more important thing that I would give you guys is, okay, let me give you an example. You have a motion sensor in one of the project and ultrasonic sensor in the other part of your project. So imagine something is not working and you're not getting the right reading. What are you going to do? You don't know which sensor is not working, right? So I would advise you when you're testing your project, have individual codes just to test the component. So imagine the motion sensor is not working. So upload a code. If motion detected, then maybe serial monitor output that motion detected. Simple code. Just send the code, check if the sensor is working. It's working, well and good. Then move on to your next sensor and always have checking codes. Because when you have multiple things, things might go haywire and you might not know where your error is. So if you have separate things to check, then it's good for you. So this is a few tips that I can give you for programming a robot. And now let's move on to the testing and debugging phase. Okay, I know testing and debugging phase is one of the phases which every single coder programmer hates, right? Because debugging is something that, points out your mistakes. And it's like one of the good things, but it's a tedious job, of course. So the one advice that I would give you guys for this is, of course, repeated trial and error method. That's all you can do. Just keep checking from a single wire to semicolon. And after checking everything, it might not work. Trust me, everything might be right. You might look at it, you're just like, everything is perfect. Why is it not working? I know it happens. It's just an annoying phase that you need to get through. Just give it some rest, give it a break, come back to it, look at what the issue is again, and just, try to debug. Don't get frustrated, don't panic, and everything. So, one more thing I would want to tell you guys is called the programmer's mantra. Have you guys heard about the programmer's mantra? Do you know what it is? You can take a wild guess, maybe. Let's look at the chat. If you can give me a wild guess about what's the programmer's mantra. Any wild guesses? Come on, guys, fast, hurry up. Okay, any responses? Okay, I will just tell you what it is. So if something works, you do not touch it, right? So if something is working, no matter how it is working, you don't know how the logic is working, you just edited a bit of the code and it's working. Just do not touch the code, okay? Do not touch your electronics, just leave it, okay? If it works, it works. So of course, abide by this programmer's mantra. Okay, I want to also give you guys a personal Codeavour experience. So you guys might face this issue on your final day of Codeavour. What might happen is on the final day, your project might stop working. I mean, majority of the times, many people's projects stop working on the last day, and it's a common thing. If it works perfectly fine, then well and good. Good for you. You're lucky. Get it through. Give your best during the pitch. But what will you do if it doesn't work? So I'll tell you what happened to me during the internationals. So my drone until the previous day, so of course, my project was Dronacharya. Until the previous day, it worked perfectly. It had no issues. We tested it in the morning. It was fine. Then suddenly in the venue, it stops working. We don't really know what's happening. We're trying to connect all the wires together, uploading code. No matter what we do, it's not working. So what we do is when we're trying to connect the wires, suddenly we just held the wires and somehow the motor started working. I still don't really know how that really happened. And our mentor said it was probably because of a current leak. And when I covered it, the current was passing through my body and, the motors were working. So we don't really know the exact reason, but no matter what we did, day one, when we were pitching our project, our drone did not work. So what did we do? We still came third, right? So what did we do? First thing, we had videos of our project. So one advice I would give you guys is every part of your project, when something works, just take a small video of it. Just take a small video, save it into a place. And when you come back to it, you can refer to it. Even especially for track two participants, take a video of every trial. And once you see the video, you'll know where you went wrong and you can correct it accordingly, right? So what we did is we showed the judges that this is our drone and this is how it was working until last night. This is a part of our video. We showed it to the judges. Then we said that, don't worry, come back tomorrow and we'll get it fixed. Okay. And then after that, what we did is we took back the drone home and then we sat over it all night. And I would also like to thank my mentor who stayed up with us till 3 a.m. trying to help fix it up online, that too. So we managed to fix the robot. We burnt a few motors and fumed a few things. And yes, the second day we got it to work. Okay. So we came back, we showed it to the judges. We showed, okay, this is how our drone was working. And the issue was current leakage. And this is what we did. So debugging, testing, and, project failing, it's all a part of your robotics journey. It's all like, you should have the patience to get through the entire thing. And don't get frustrated. Don't panic if something doesn't work. Just calm down, take your stand, tell the judges the problem. They will understand. Okay. And show them the videos. And of course, analyze the mistakes. And one more thing, you guys might have heard about something called jugards. Jugad is basically a trick that you can use. Okay. So I told you, I mentioned when I cover my hand, the motor started spinning. So we tried to cover it with foil. And the only foil we had was a sneakers wrapper. We tried covering the wires with sneakers wrappers, tape it together, try find all kinds of metal components, try cover it. Nothing really worked. But yeah, you can definitely use these kind of jugards and get your project to work. Just try fix it somehow. Something doesn't work, there's always a way to find it. And you'll always have a mentor to assist you as well. And if you need assistance from me, I'm always there for you. And yeah, this is about testing and debugging, and we can move on to the next part of it. It is refinement and optimization. So for refinement and optimization, you should always do better in the next level. So let me give you two perspectives. First, the track one perspective. You have your regionals, nationals, and internationals. For every level of your project, add a new feature. Just think of a new feature and add it. Okay. And always add a new feature after your first few features are proven to be the best. Okay. So maybe in regionals, a part of your project fails. And you've qualified for the nationals. That's amazing, right? So that time, sit, debug, find out what was the mistake, try to make the first part of your project perfect. After that, you'll have ample time until your nationals. Add a new feature, make it more better. Then after that, for your internationals, make it even more better. And you'll be the best in the room. Because in your regional, some people would have seen your project and you just come in with a new feature and, boom, everyone's surprised, right? So that's how you have your refinement and optimization. And for track two, of course, when you're, completing the specific tasks, some tasks may not go as planned. Of course, as I mentioned, make a video of it, check where and what was the loophole in your entire project, fix it. So this is the refinement and optimization that you can do. And also, as you can see the video on the right? First, you saw a surgeon robot, which was just with like 4 arms, and now you see a full setup. This was the refinement and optimization in the PPT. So you should always try to do something better. And this is just about refinement and optimization, and we can move on. So now you can see two videos side by side. It's a drone and It's my humanoid robot, Saki. You can see its few actions. It's moving up, down, left, right, and this one is coming front and back. So we just discussed about everything, right? What are the components used, how to build everything. So now look at the two projects and tell me what are the materials that I used in both of them. Come on, put it in the chat. Tell me what is the difference in the materials. I want you to tell me from the structure to the motors to the battery, probably sensors, everything. What is the difference that you can see in a drone and Saki? Come on. Let's see what can you put in the chat? Okay. Come on, hurry up. I want to see what are the differences that you guys are thinking of. Okay, electronics. What kind of electronics? What is the different electronic components I'm using? Obviously, drone and robot on land is different, right? Something that goes around in the sky and something that's on land. It's two different things. What is the difference? You can tell me based on the motors, what kind of motors am I using? Look at the two materials I've used in the project. Yeah, Arduino Uno, Arduino Mega and Saki, propeller. Okay, nice. Then motors, okay. Arduino normal motor and vibratory motor. Good job. ESP32, okay. Drone can fly, Saki cannot. Okay. So why can the drone fly? What is the special thing about the drone? Come on. Okay, DC motor. Good answer. Okay. So basically, you guys got a gist about what are the materials required, right? Arduino Uno, Mega, lighter microcontroller, Quirky than Evive, of course. Body 3D printed, servo motor, ESP32. Okay, great answers. Now I'll tell you the key differences. Let's move on to the next slide and see the key considerations that involve in the robotic design. First, we have the weight and size. So, drones are supposed to be light. They're supposed to, go up in the air. So that's why, and you want it to be sturdy. You don't want the wind to just, push away the drone somewhere. So that's why I have used high quality plastic for the drone. Okay. So high quality plastic for the drone is the main feature. Then for Saki, right? It's just going to be inside my house. It's safely protected. So that's why I've used thermocol. I just wanted to be light, safely protected at home. Thermocol. Next, moving on to the mobility. Mobility. You saw the drone. It has to, fly up how many meters high, exclude all the air pressure and, it needs an upward thrust. That's why we'll be using 1000 kilowatt brushless motors. Okay. But in Saki, it just has to go front and back on land. How hard could that be? So simple DC motor with like, a few wheels and caster wheels just does the job, right? That is the difference between mobility of a drone and mobility of a humanoid robot. This is one of your most important objects for your track too. You want it to move around in that small path, right? You'll have your different sensors and, the motor speeds and everything. Then moving on to weaponry. This is most important for your combat robots. Okay. So for your combat robots is basically you attacking another robot. So maybe, you have your robo sumo kind of tracks and you also have probably, you just want to have a Beyblade fight with a robot. You may never know. So you need a spinner, right? Spinner, fidgets, or maybe a hammer to crush your opponent's drone. So accordingly, you can use weaponry and, make your robot as strong as you can to crush the other person's robot because, that's the goal of the project. Then moving on to the armor, the most important aspect of your project. What is the outer covering of your project? How are you safeguarding your electronics, right? So in Saki, all the electronics are safeguarded behind the robot into a thermocol case. But in a drone, it's fitted under the drone so that the propellers don't cut off the wires, correct? So this is how you can differentiate between the armory and also for your track to ensure all of the armory is covered into a one strong case and none of the items move around when you're performing your tasks because even a single loose screw or a single loose wire will actually mess up with your entire project. And talking about the design, as I told you guys, maintain a notebook. You can see a picture of Saki from my notes. And when I was looking at the design, I built the robot and I kept it in two different orientations just to look at how I want to place the head, right? So designing aspect is all about how you want it to look, how you want the others to look at the robot. So whatever looks good to you, trust your gut and go with that design, okay? Just, don't think about how bad or how good your robot is going to look. It's all about the functionality. And of course, presentation matters as well, okay? Now let's move on to the next part. It's your electronic requirements. So your electronics can range from microcontrollers, sensors to actuators. How do you choose a microcontroller, right? So you can choose your microcontroller using, the functionality you need from it. So as you can see in the few pictures, I've used Evive in a project and I've used Arduino in the project. And if you look at the bottom two pictures, you can see both of them are connected to the same four sensors. Correct. But the difference between the right side of the picture and the left side of the picture is that extra servo motor that you can see, right? So I've used Evive because it has its own servo motor jack and it's just easier for me to, plug and play. But I've used Arduino because, I have to just use sensors and there are four sensors. So I need more number of pins. And that's when I choose a Mega. Correct. And if you want effort, seamless wireless communication using ESP32. If you want, stronger power in your microcontroller, you want to do multiple tasks at the same time, go for Raspberry Pi. And based on what is your problem statement, what are the functions you wanted to do, you can choose your microcontroller. So here we have Arduino Mega and Evive. You can choose whatever you want. Now moving on to the sensors. Sensors is again based on your problem statement. So let's assume I want to build a project which is a fire extinguisher. So to detect fire, you're going to use a fire sensor. Correct. So when I'm using a fire sensor, I detect the fire, capture the reading, get it into digital and analog. You should also find out which is the digital and analog sensor that you want to use, right? Or if I want to measure the distance between me and the laptop I'm sitting in front of, I'll use the ultrasonic sensor. Then if I want to check if there's a motion detector, if there's someone at my door, I want to know, I'll use a motion sensor, PIR motion sensor. So accordingly, based on your tasks, you can use the sensors. So as the ones that I mentioned, ultrasonic and gyroscopes, of course. Then moving on, we have our actuators. So actuators are something that control the movement. So, it can range from your DC motors to move your robot front and back, drone to lift it up and down, move it front and back. Then also another actuator could be a servo motor. Servo motors are mostly used in robotic arms. If I want a robot to say hi, I'm going to use a servo motor because I can control angles, right? So use whatever actuator you want according to your robot preferences. And yeah, moving ahead, let's give you a simple, fun question based on the video. So guys, watch the video and the robot is doing a particular task. Name the task and tell me the sensors that are being used. And yeah, of course, name the actuators as well. Come on. What are the sensors and actuators used? This is a robot just, doing a particular task. It's pretty clear what it is doing. Tell me what it's doing. Okay, let's have the answers rolling in. Okay, I got a few sensor answers as well. Smoke sensor, camera, gyroscope. Nice. Okay, I want you to tell me what sensors is this particular robot using. Line sensors. Okay. Line sensors. What is the actuator, Ravi? Come on, name the actuator as well. Line following robot. Okay. Okay, great job, guys. Come on, you know what it's doing. So the sensor is line sensor, right? Line following robot, Arduino, IR sensor. Good job. Yeah, so basically this particular robot is using IR sensors to detect the black line and, move around and perform its actions. Okay. Now this is how you choose your electronic component based on the purpose. Let's move on. Now moving on to the key consideration, power source. So this is one of the things which most of us would neglect when we are building a project. Because, when we are looking at a power source, if I'm using an Arduino, it's giving me a 5 volt, 1 ampere current. So I would just take a direct 5 volt connected to a servo motor and I would try to control okay, imagine I'm building a robotic arm. I'll need 3 to 4 servo motors for it, right? So what would happen? The Arduino won't be able to supply enough current. It might provide voltage, but it won't be able to supply enough current for it. So power source is one of the most important things. Always check the power rating of the component you're using. LEDs. I mean, you guys might have had some fun, right? Your sir would have told you not to connect a 5 volt and a ground. Just connect it and boom, LED bursts, right? Try it out. Okay, I wouldn't advise you guys this. Be safe. But yeah, It's basically going to burn your LED because you're passing a higher voltage through it than what it can bear. And that's exactly why we use resistors. Okay. So ensure you check your power rating and, check how much current and voltage you need. So about power source, I want to give you a personal experience. In one of the competitions I was a part of, I was working on a robotic arm, and robotic arm had around 3 servo motors. And what we're trying to do, robotic arms have to lift off heavy objects, and there wasn't enough power for it. So we, directly assumed it needs more current. So, human mind would just assume, okay, put some more extra batteries and, get the project working, right? But what exactly happened is we did that. We added a few extra batteries, connected it together, and a few hours before our project, our competition might be just 2 hours away, we burnt all our servo motors. And now the robotic arm is fully assembled. There's 2 hours until the project, and we don't have a project, right? So what we did that time is we realized we supplied more voltage and more current. Then we had to reduce down the batteries, do a few calculations, check the rating of the servo motor, supply the right amount of current. And that's when we got it to work. And yes, we made it to the competition as well. And yeah, that is very important. And one more thing is if you supply a higher amount, then everything is going to burn off. I mentioned even in the drone, we burnt a motor, right? Things like this are going to happen. Learn through your mistakes. Your drone, I burnt a motor, and if you supply low voltage, it just won't work. It just won't, robotic arm won't even pick. So this is why power source is one of the most neglected, but one of the most important things in your entire project. Okay, now let's move on to the materials and tools that you need to build your robot, right? So this is basically us summing up whatever we did so far. First, we have the frame or the chassis. This is the main structure of your project. It is the framework. So imagine a body, right? If it doesn't have a skeleton, how is it going to be? Just a bunch of, just a bunch of muscles, just, there. So skeleton is your frame to your body. So it's also the frame to your robot. And for Tractor especially, what kind of frames you have to build. It's a very important aspect. It kind of, makes your project stronger, sturdier, easy to make it travel, etc. Okay. And it also supports all the other parts of your project. You need that, right? It's a supporting mechanism. Then moving on to your sensors and actuators. As we mentioned, there are multiple sensors and actuators that you can use. Sensors are basically used for detection of objects, gather all your data, convert the readings, perform if and else actions on it. And your actuators just give you the output of that particular thing. Actuators are something, I get an impulse and I, tell it out to you guys. So that's basically an actuator. And of course, sensors and actuators, we spoke a lot about it throughout the session. Now, moving on to the mechanisms. This is very important, right? Especially for both the tracks, actually. So considering looking at it from the tractor perspective, if you want to like maybe, pick something and go drop it off at another place, then you need to know what kind of arms or mechanisms that you need to use. You need to get the perfect configuration. Like, look at my arm. If I want to grab something, I'm going to do this and grab it, right? So there's a particular design element that you need to focus on while thinking about the mechanism. There's also a session taken on Codeavour, a YouTube channel. Go check it out. There's a session on mechanisms. You learn more about how to use your mechanisms, effectors, and everything. So ensure everything's the right amount of configurations. You can 3D print your parts for it, actually. Customize it and, get your mechanisms working. Then, of course, you need the brain, right? You need to control all of these. You need something that's going to be the head of everything. That's called your brain. It's called a microcontroller. Evive, Quirky, Arduino, use whatever you want, control your robot the way you want. And yeah, this is basically about the materials and gist of how to build a robot. Now, moving on, let's see a really fun thing, Quirky Creator Kit. Have you guys used it? So also one more important thing I forgot to mention to you guys is whenever you're buying an electronic component, get it from an authorized dealer. Okay. So getting the right components which work are more important to build a project. Or else the debugging phase will be longer until you realize that your component is the faulty one, though your code and connections are perfect. So I would say Quirky Creators Kit. Stempedia Codeavour is one of the authorized sellers as well. You can purchase the Quirky Creator Kit, and the Quirky Creator Kit has a few features like advanced PD line following features. And I spoke about mechanisms, right? You can look at the picture down. It has a few mechanisms. It has a few, elements that you can use to build your track 2 robots, even track 1. You can have your own machine learning models. And of course, use your Quirky to play around, use it with different sensors, actuators. It's a very easy model to play around with. And especially if you're a beginner, definitely recommend it. Go for the Quirky Creator Kit. And yes, wrapping up the session, scan the QR code for any learning resources. I'll give you guys a minute to do so. Scan the QR code, you'll get all the list of the sessions we have had. There's a Quirky resource on the page, and yeah, you can check it out. And if you guys have any doubts, please put it in the chat box and we'll answer them. Okay. Are you guys done scanning the QR code? Do you guys want to move on? Come on, guys, done. We can even make a line follower using Quirky. Yeah, sure. It has advanced line following sensors as well. There's a special extension in PictoBlocks that you guys can use. Okay. I think we've given you a minute to scan the QR code. Give me a thumbs up in the chat if you're done scanning the QR code. Come on. I want to see a bunch of thumbs up in the QR code, in the chat box. Come on, guys. Okay. Yes, yes. Where are the thumbs ups? Come on. I want to see all the thumbs ups. Could you give some topic that you would like to see in track 1? Okay, see, there are obviously, themes in Codeavour, and one of the most important thing is combating climate change, right? And that's one see in track 1, because climate change is something that's affecting all of us. You see, even right now in India, the seasons have been delayed, correct? So let's see what creative ideas you can come up to, protect the environment. For me, whatever I want to see in track 1 is something that can help the society. Always aim to, help the society in whatever you build. So even if you notice my projects, everything is targeting a specific target audience. And that's how, empathize with them, and then you can build your project. Okay, great. That's a lot of thumbs up. We can move on to the next part of it. So guys, feel free to reach out to me if you need anything. You can reach out to me on Instagram, LinkedIn. I'm also on the Codeavour community. And yeah, I'm always going to be there to offer assistance and help you with anything you need. You can pin me up your doubts or mentoring, or, if you want just to discuss the idea with me, sure, just ping me. So yeah, thank you. Thanks a lot, guys, for joining. It was really fun having you all. I would like to hand over the session back to Vivek, sir. And thank you.
Thank you so much, Samriddhi, for this amazing session. I have to say, everybody who joined us have learned a lot from you today. What exactly robotics is, how exactly to build a robot, what are the steps that one should consider while making such competitive robots. And even you shared your notes and screenshot of your notes, and just everything that you experience you have shared throughout this particular session. I'm so happy, and everybody who have joined us, they love the session. I have to say it to the chat box. Thank you so much, Samriddhi, for this amazing session.
Thank you, sir. Thank you for having me here.
Thank you so much. So make sure, guys, ask Samriddhi, ping Samriddhi with your questions or your ideas that you have on her Instagram or her LinkedIn. You can just go and follow and check her page. She will be more than happy to guide you throughout. And of course, the entire Codeavour team is also here to help you out. Make sure you like this particular session. Subscribe to our channels, because we will be coming up with more such sessions. We will be helping you out in every way possible. So make sure you like this particular session so that Samriddhi also feels motivated, right? Thank you so much, everybody, for tuning in. We will see you another time. Thank you.